Hi, this is Deepak, and I am presenting my code that I have used for my research in data analytics. So this is the Colab code. This is the Google Colab website where I'm using to run my code to make my model, train my model there, and predict the values. So we start from the dataset. Dataset is picked up from butterfly and moth image classification 100 species from the Kaggle. I have manually downloaded that and uploaded it to my public Git repository over here, and it can only be accessed from me now, and it can only be accessed with the code over here. So here I'm using let's see, go from the structure. So first I will be adding all the required libraries, then importing all the necessary libraries over here. Then I'm cloning all the GitHub files over here. It is basically cloning all the data sets to my local storage. And then from function required, I am using different functions to plot the image, then for create the image data set and plot the loss graph for every particular model when we run for when we do evaluation of that model, and for accuracy of the model. And this is for evaluation and printing the accuracy and classification report. Here I'm doing the GPU check, as this code is taking 1 to 2 hours, nearly 1 hours to run. So I have already run the code over here. As you can see, it's connected to the RAM and it's running. And here we can see the GPU's time. And here after that, in the image preprocessing, I'm removing the dodgy images using this particular function. This function is used for count the image. So here, if you do check under the ED, I have done that loading the image, and now I am you can say here I am using I am using those functions to represent that count. So you can see training, we have hundreds of models, 100 in test, 100 in valid, and the images for training is 12,000, and for testing is 500, 500. Going forward, we are doing the visualization for class imbalance over here. So here you can see we have different class names. It is butterflies and moth species names as a folder name, and the image counts how many images we have. For better understanding, we have the bar graph over here, which shows how many images we have for this particular uh, species. So there is no such class imbalance. So we are going ahead with those training images. After that, we are building the ButterflyNet CNN model. In CNN model, I have started with convolution layer with ReLU activation and image sizes 224 and 224. And after that, I'm doing batch normalization and max pooling to desampling, retain the important information, and batch normalization for stabilizing the model, and dropout for prevent the overfitting. After that, I have added same multiple layers for it. You can see the 4 layers over here, and additional layers I have added to wedge normalization and dropouts, because to make it more the images of butterflies and species, they are very different insects. The colors are different, the patterns are different, so that it can refine more. And then I converted those 3D to 1D and compiling with the learning rate over here. And you can see we have 31 MB of parameters over here. And after that, I'm training the butterfly models. So here you can see, like, sometimes the accuracies, and every time you run the code, the accuracy go might 1% or 2% over, or just plus and minus. So keeping in that mind, I've just run this code over here. So you can see I have provided the patience level 3 over here, and epoch is 50. So it will just keep on checking if there is no going forward, like no changes is being done in the training of the model. So after 3 epoch runs, it will eliminate there. So that's why I have added patience and then the epochs, and we are doing callbacks using unleash topic. So here in this run, we are getting 19 epochs with 86% of validation accuracy. Then there is a plot over here, and you can see on the accuracy plot for the training and the validation over here. And if we see the evaluation part of the butterfly net, here is the confusion metrics for on the test data that I have done. And after that, at the end, we can see the accuracy of the model over here, and the total accuracy for the test images is 88%, and 0.36% is a trust loss. And then we are training some pre-trained models from the from the image net, and using that. So to check our models over here and compare with the ButterflyNet. So I have done if I used EfficientNet, VGG19, and ResNet 50. And EfficientNet here you can see we have used the same like learning rate and everything kept same so that it can be compared. The results can be compared at the end. So here for the training, same everything is kept. So 7 epochs, and we get 93% of the test accuracy with test loss of 0.24, and we get the plot performance over here. That is right decline over here. This is not validation accuracy is not changing that much in this one. Then go for VGG19. In VGG19 we have 6 epochs with test accuracy of 93 and 26.26 of test loss. And here the same we go for the accuracy and plot. Then we go for ResNet 50. ResNet 50 also taking 5 epochs with 2 patients level. And here we can see the uh, mm, loss of information for the validation is not for the validation is not so much, and the training loss over here. And then we see the accuracy over here. Accuracy of the model is good, and then evaluating on the test data 94%, which is highest for all the models, and 0.22% as a loss. So here you can see the comparison of all the models over here. Resonance 50 is for 94% with the lowest loss. So this Resonance 50 is making a good progress, and Resonance 50 is good. But even if the ButterflyNet model is new model that I have created with 36% of loss and 88% of accuracy, I think we can do some future work over here and it can be better. Coming to the deployment part, Streamlit is a Python library which is using to create a website over here. So I have used this, and I will show this how we are doing it. So for running the website, we are tunneling it through the local tunnel using npx. So this code will make it run over here. So here they have given a every time they give a different URL. You go over here, you copy the external link, and we tunnel. We give just the IP address over here. We remove this. Click on submit, and we can get our user interference over here. You can see as a good user interference. We click on let's go, and user have access to all the models. There we have. So let's start with the best model we have, Resonance 50. And after Resonance 50, we have to uh, check with, let's say we start with let it load. And we go from browser the file, and we go for the test data here. And let's go for a heuristic. Moth. So here you can see it's very complex colors and structure. So let's go with this one, if it can recognize or not. So see here, garden tiger moth with 54% of confidence. So this is correct classification. Let's try with any other test image. Let's go with 5 point swallow. See the different colors it have over here. So it makes more complex the structure. Let's see if it can find it or not. Spy and swallow. Same way we can do it for ButterflyNet. If we directly change from here, it can change over here. So for the same image, so you can see the ButterflyNet is not able to recognize this, and for VG16, it is able to recognize it. So this is my project. Thank you.